Hello everyone, I am Surendra, Master Teacher of Mathematics in Vedantu. As I am taking these sessions on ISI and CMI every week, these sessions are also important for JEE Advanced. In today's session, I will be solving one of the paper of CMI, that is 2019. As you know, CMI is having two parts, part A, which is having fill in the blanks type questions, and part B, which is having subjective type questions. In today's session, I will be solving part A, and then I'll be sharing one teaser question also. So do not forget to go through that and please solve it and please send these solutions to us. Okay, so let us start with the first question, in which we are given for a natural number m, phi 1 m is the number of divisors of m, and k greater than or equal to 2, define phi k m is equal to phi 1 of phi k minus 1 m. For example, phi 2 12 is equal to phi 1 6 is equal to 4. Then find the minimum k such that phi k of 2019 raised to the power 2019 is equal to 2. Now first of all, let us understand what exactly this function is doing. Suppose you have some number, let us say 20. Okay, so this function is actually counting the number of divisors. So to count the divisor, we write this as a prime factorization, which will be 2 power 2 into 5 power 1. Okay, so now to get number of divisors, what we can do, we have a choice to choose power of 2 in three ways. We may choose 2 power 0, we may choose 2 power 1, or we may choose 2 power 2, one very standard method to find the number of divisors. And similarly for 5, we have two choices only, either 5 power 0 we can choose, or we can choose 1 also. So we will always increase this power by 1, and then we will multiply them to get the number of divisors. So we get answer to be 6. Now dear all, please understand, here there was no role of these prime numbers in the base. The only role was that of the powers that are on these prime numbers. So the value of phi 1 will depend upon how many prime factors are there in the base and what are their powers. For example, if you find phi 12, phi 1 12, this will also be same, because phi 1 12 means it will be phi 1 of 2 raised to the power 2 into 3 power 1. So it is same pattern, so it will also be 6. Now what phi 2 is, as they have explained, phi 2 12 means it would be phi 1 of, and as k is 2 here, so here it will be phi 1 of 12, phi 1 of 12 as it is 6. So what we need to do, we need to find the number of factors once again, and we can write 6 as 2 power 1 into 3 power 1. So using that method of number of divisors, it will be 1 plus 1 into 1 plus 1. So answer would be 4. So this is what they have explained in the question itself. Now the question is, what is the minimum value of k so that phi of k will be equal to 2. Phi k of 2019 power 2019 would be 2. Now to do this, I think we first need to find the number of divisors of 2019 raised to the power 2019. Now to do this thing, we should first find the prime factorization of 2019, which is actually 3 into 3 6 18, then 7, and then 3, and whole power 2019. So for this we need to first find the number of divisors, and for that I think I need to write this as 3 power 2019 into 673 raised to the power 2019, and this is to note that 673 is a prime number. It is not direct to conclude. You have to do division by 3, 5, 7 and so on, and you will realize that it is not even divisible by 23 or 29, and we just have to go only up to number that is smaller than the square root of this, and we can conclude after that this will be a prime number. So here if I need to find phi 1 of this, it would be 2020, one addition to this 2019 into 2020 will be after adding 1 to this, and 2020 here as well. Now 2020, if I do the prime factorization, I can take 4 common, then it will be 505. 4 is 2 power 2, and then I can take 5 common, and then it will be 101. 101 is also prime number. So if I need to find phi 2, I need to find phi 2 of 2019. raised to the power 2019. Okay, then it is actually phi 1 of this thing, because phi 2 means phi 1 of this thing, which is 2020 into 2020, and I will like to write this as 2 power 2 into 5 power 1 into 101 power 1. Now you can find the factors of this by adding every power by 1. So 2 will become 3, then 1 will become 2, and this another 1 will become 2 here. So number of factors of this 2020 square will be 12 here. Okay, and this is actually the value of phi 2 of 2019 raised to the power 2019. We are supposed to find when will this become equal to 2. So I think I need to find now phi 3. Phi 3 of 2019 raised to the power 2019. Now this would be phi 1 of phi 2 of this thing, and phi 2 of this we have found was 12, which means 2 power 2 into 3 power 1. And I think I can write this directly. We have already seen it before. 3 into 2, that is 6. Okay. Now once again, if we repeat these things, 2019 power 2019, it will be phi 1 of phi 3 of this, and phi 3 of this is 6, which is 2 into 3, and I can write this as 2 into 2. So again we are not getting this as 2, and but 4 is 2 power 2. So to find phi 5 of 2019 raised to the power 2019, it will be phi 1 of 2 raised to the power 2, which will become equal to 3. Okay, now 3 is a prime number. Okay, and phi 6 of this 2019 raised to the power 2019 will be equal to phi 1 of 3 power 1, which is nothing but 2. Now if you again do this thing like phi 7 of this, if we find, it will be phi 1 of 6, that is 2, because 2 is also prime number, it will again be 2. So if you keep on doing this way, you will always get only 2 as the answer, but they are asking the minimum k for this. So I think k minimum for this question would be 6. So answer for this question is 6. Now dear all, we might have been thinking that why can't we do it reciprocal. Okay, now to do this reciprocal means that we first think that what is the number for which number of divisors are 2. But I think that method is not correct in that sense, because 2 will be the answer for every prime number. As you would have seen, for 3 power 1 or 2 power 1, every time number of divisors are 2. So going in the reverse manner, reverse order of the solving will not yield the answer. So I think we should go this way only, and we have to do the prime factorization again and again, okay, to get the answer. So this completes this solution of this question. Now coming to the next question, that is 2. We are given that f is a real valued continuous function defined on R, satisfying f dash tan square theta is equal to this for all real number theta. First of all, I think for all real number theta, instead of giving this thing, they would have given that theta belongs to R minus 2n plus 1 pi by 2. Because at these numbers tan theta is not defined, or they would have given all real numbers tan theta or tan square theta, you can say. So they would have given this way also. So I find small I should say small correction, you can say, or small modification in the language of the question should have been there by doing these small changes. One more correction was there, that phi dash 0 should not have been there. It should have been phi 0 is equal to minus cos pi by 12. Now first let us solve for f dash tan square theta. So what we are getting here, f dash tan square theta would be, we can write cos 2 theta as 1 minus 2 sine square theta. Tan theta can be written as sine theta upon cos theta, and sine 2 theta is 2 sine theta cos theta. So you can see for cos theta not equal to 0, we can cancel this cos theta, and cos theta will not be 0 if we take theta like this. Okay, and here you can see 1 minus 2 sine square theta plus 2 sine square theta, these will cancel, so it will be 1 only. So that means my f dash is coming out to be 1 always. That means derivative is constant. In fact, as you can see, so I can say, means by this tan square theta, what I was supposed to say that tan square theta is always greater than or equal to 0. It may go up to infinity. Okay, so this fx is f dash x is equal to 1 for all x that belongs to 0 to infinity. Okay, that means slope is constant, and you may call this as a straight line function with slope equal to 1. So we can write this fx as mx plus c form, okay, in which m is 1 and c is value at x is equal to 0, isn't it? If you put x is equal to 0, we get f0. So here this would be f0 here, and we are given f0 also, and they are asking what will be f1. So to get f1, I can write this as 1, and the value of f0 is minus cos pi by 12. So we may leave answer here, or we may write this as 2 sine square pi by 24, or you should remember the value of cos 15 degree. This pi by 12 is 15, which is root 3 plus 1 upon 2 root 2. So you may give your answer in multiple formats. So 2 root 2 minus root 3 minus 1 upon 2 root 2. So this completes the solution of this question. Okay, now coming to next question, but before that let me tell you this was easy question, although there was a correction, so they would have given a bonus. So I think you might have wasted some time on this question, because in the exam it will be confusing that phi dash tan square theta is coming out to be 1, but they are saying phi dash 0 f dash 0 is minus cos pi by 12, which cannot be equal to 1. So this was a bit confusing, I think. Now coming to question number 3, it says you have a piece of land close to river running straight. So let us assume this is the river and this is running straight. This is one of the edge or one of the shore of this river. You can say you are required to cut off a rectangular portion of the land with the river forming one of the side of the rectangle. So your fence will have 3 sides on it. Okay, so they are saying if you make a rectangle this way and you want to protect this rectangle from outsiders, so you have to place your fence only on these 3 sides, because one of the side is taken by the river itself. So suppose my dimension of this river are A, B, so this will be A here also, but this side B I need not to make any fencing, and we are having 60 meter of fencing. So they are asking what will be the maximum area we can enclose using this 60 meter of fencing. Now if we want maximum area, then obviously we will be using the entire length of the fence, isn't it? If you will use only 50 meters, definitely you can cover more area if you use the entire fence. Okay, so first of all you should understand that in this diagram 2a plus b would be equal to 60, and we need to find the maximum area. So my area will be equal to a into b. Okay, now there can be multiple method to find this maximum. There can be one of the method using the quadratic, one can be AMGM, one can be application of derivatives. Here I can write a into b as a into 60 minus 2a. Okay, I will take 2 common, and then it will become 30a minus a square. Right, in 2 outside it will become perfect square of 15 square minus a minus 15. It can be checked, and these things are very elementary. You should be having sufficient enough practice to write these things very quickly and without error. Okay, now you can see this is a perfect square, so it has to be positive or minimum value will be 0. So from this I can say my a maximum would be when a is equal to 15. So it will be 2 into 15 square. So maximum area will be 450. So that is the one of the method I was suggesting. Now what can be another method? Please see method 2. Method 2. 2a plus b is 60. So if I take am of this and I write this to be greater than or equal to gm, I think this is how we can write. 2a plus b is 60, so this will become 30, and if I do the squaring, so 30 square will be greater than or equal to 2 into A into B. So my AB will be less than or equal to 450 from this also. And this equality, that is AMGM, will happen if this 2A is equal to B. And 2A plus B is 60. So this will be when it is equal to 30 each. That means A is equal to 15. And you can see the same conclusion we were getting from here also in our method number 1. Okay. Method 3 of AOD, application of derivatives, where maximum minima is found, is actually nothing but doing the differentiation of this equation. And then you can find where will be the point of maxima and whether it is a point of maxima or minima, and then by putting that value of A, you will get same answer. So what I am suggesting, I just write one step, dA upon A. If you do the differentiation, you will get 2 outside and 30 minus 2, and you can check this becomes equal to 0 at A is equal to 15. And it can be checked. I am not doing this method because it's very easy, that A equal to 15 will give you point of maxima. So area maximum would be 450 when A is 15. So I think this one is also, I will consider this as an easy question, because you have seen such questions in detail or difficult question than this even in your NCERT book of AOD of mathematics, and even higher level question in other books. So this I will rate as an easy question. Okay. Now coming to next question, that is 4. We have to find the sum S is equal to 1 plus 111 plus 5 times 1 and then 2k plus times 1. This is, I think, one very standard problem. We may have done this type of question in geometric progression, sum of n terms of GP. It is not GP, first of all you should understand, but you can convert this into 1 or 2 GPs and you can use the formula of sum of n terms of GP to find this sum. Let us see how. We can write this S as, after dividing by 9, this will become 9 plus 999 plus 99, 5 times 9 and so on, and then this 99 2k plus 1 times. Okay, and then when you standard step, I think 9 will be written as 10 minus 1, 999 will be written as 10 cube minus 1, then it will be written as 10 raised to the power 5 minus 1 and so on, and then it will be 10 raised to the power 2k plus 1 minus 1. So dear all, you can see it is actually sum of one GP whose first term is 10, common ratio is 100 and so on, and number of terms, how much, let us see how many number of terms will be there, because that will decide the exact sum. In fact, this 1 plus 1 also we need to check how many times we have written it. Okay, is it k times? This is one very important thing to understand. Okay, as you can see in my first term, 1 was appearing 1 times. In second term, 1 was appearing 3 times. In my third term, 1 was appearing 5 times. So my first term is 1. I may write this as, let me say this is 2r minus 1, because if you put r as 1, we are getting number of times 1 is appearing. Okay, and then 3 when r is put 2. So in second term, you can say my number of occurrence of 1 is 3. So we can say the number of occurrence is given by 2r minus 1. For r is equal to 3, you can see it is giving us 5. Now if I want the occurrence of 1111, 2k plus 1 times. Okay, so in the last term, okay, I think the value of r here would not be k, but rather it would be k plus 1. You can check. 2r minus 1 is giving us the occurrence of number of times 1 is occurring. So here r has to be k plus 1, it is not k. I think this could have been one of the catch and where student would have done this question as wrong. So if we have found it, then I think question is done. 1 by 9 outside, first term is 10, then 100 power it would be k plus 1, because number of terms are k plus 1 minus 1 upon r minus 1, and 1 will be k plus 1 times, so k plus 1 here as well. I hope you have understood why this k plus 1. If you have not understood, please go through, rewind this video and see it again. So here it will be 1 upon 9 into, I can write this as 10 raised to the power 2k plus 3, because this 100 is 10 power 2, so 2k plus 2 plus 1, so 2k plus 3, and minus 10 upon 99, and minus, I think, k plus 1, or let me write 1 by 9 outside only, so like this. So that will be the answer. You may take 99 as LCM, and it will become 10 raised to the power 2k plus 3, then minus 99k, and then minus 109, I think, 109. So that will be the answer of this question. One very standard problem of GP, the only difference here is they have made the gap of one term. Otherwise, we would have seen the question where 1, then 1, 1, then 3 times 1, then 4 times 1. Here they have skipped the occurrence of even times. Only 1, 3, 5 they have taken, and last term was given little bit in trickier manner so that you make a mistake. Here that was the tricky part, I will say, for this question. So I will call this question to be easy to medium, you can say. Okay. Now coming to next question, that is question number 5. It says we are given 8 into 8 chessboard and 2 distinct squares are chosen uniformly at random. Find the probability that 2 rooks placed on these squares attack each other. Recall that a rook can move either horizontally or vertically in a straight line. Okay, so what exactly they are saying, that suppose this is my 8 into 8 chessboard. I will not make all the box, let me make all 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so they are not evenly distributed, but I hope this will serve the purpose. 1, 2, 3, 4, 5, 6, 7 and 8. Okay, now if we want the 2 rooks to be placed only horizontally, to be placed in the same row, I would say, or same column, because it moves either horizontally, that is in the row, or vertically, that is in the column. So I have two methods. Please understand how this can be done. My first method is that in which row I am going to place the 2 rooks. So which row? I am having 8 rows. So 8C1 ways to choose which row I want. Now suppose I have chosen this row. Now in this row I may put my 2 rooks into 8C2 ways in any 2 of the boxes, you can say. Okay, and if you want to consider the occurrence, the order in which they appear, that may be black rook and white rook, then you may do 2 factorial also here. Okay, then that is the thing that we require. One more thing, that this was only for the row. The same thing can be repeated for horizontal also. So into 2 will also be done if you want to find 2 boxes in that vertical column. Now what will be the total number of ways? I think there are 64 boxes and we want 2 to be chosen from them, and into 2 factorial. Okay, so that is what we need to solve. So 8C1 is 8, 8C2 is I think 28, into 2 into 2, 64, C2 is 64 into 63 divided by 2 here into 2 factorial. That is 2 only. So let me cancel this 2 with this 2 here, and 8 into 2 is 16 into 2, 32, and let me take 1, 2 from here also, that will cancel this 64. And now I think we can divide this by 7, so 2 here and 9 here. So that is the answer of this question. Very easy question, isn't it? Now I will tell you one more method of this question. Please see what is that method. My method 2 is that we put my one of the rook in any of the box, or let us assume this one. Okay, so the required probability that you put my first rook in any of the box. So you can consider that it will not decide my probability because you can put in any of the 64 boxes. Okay, but now my second rook will decide whether they both are in the same horizontal row or vertical column. Now, if my rook is here, then you can check in this row 1, 2, 3, 4, 5, 6, 7 possibilities are there for the second rook, and for this placing of first rook, I think I am having 1, 2, 3, 4, 5, 6, 7 places in that vertical column also. So you can check after placing first rook. For second rook, I am having 14 places where I can place my second rook, and that will satisfy the given condition in the question. But if I put it randomly without thinking anything, then I think I'm having only 63 boxes because one place was already occupied by this rook, so only 63 out of 64. So here also you can check, it comes out to be 2 by 9. I think this is little easier, isn't it? So, but this is also good. You should know both the methods and you should understand how both of them are giving you the same answer. Sometimes students complain that my one of the method is giving me some answer, other method is giving some other answer. The only reason for such things are that you have done some mistake in your one of the method. If you apply to different method, you do not get different answers. Okay, so this is how this question 5 is done. Again, I will put this into the category of easy to medium only. Coming to next question, which is from number system, for how many natural numbers n is this n power 6 plus n power 4 plus 1 is a square of a natural number. Okay, so this kind of questions we do normally under the heading Diophantine equations. Okay, so here I'll take this as a perfect square. So the idea which I got to solve this was that let us take this as m square, because it has to be a square of a natural number, so m is a natural number. Okay, now you can write this as n power 6 plus n power 4 is equal to m square minus 1, whom I can write as m minus 1 into m plus 1. Okay, let me take n power 4 common, and this will be n square plus 1. Now few things I will be concluding here. Number one, that this left hand side here has to be odd. Why it is odd? Because if your n is even, then it is odd. Even plus 1, it will be odd. And if n is odd, then also odd plus 1 will be odd. So if LHS is odd, my m has to be odd number. M has to be odd number. Let us see if it is required in this question or not, but m is odd. Okay, now if m is odd, then you can see m minus 1 and m plus 1, they both are even. Okay, in fact, both even numbers, rather both consecutive evens. Why I am saying consecutive even? Why it is important? Understand this thing. Any two consecutive numbers are always co-prime. Consecutive numbers like 7, 8, 8, 9, 13, 14 and so on. And similar to this, any two consecutive even numbers have only 2 as a common factor. M minus 1 and m plus 1 has only 2 as common factor. Why I am saying so? Because m minus 1, m plus 1 being two consecutive even numbers, one of them will be divisible by 2 only and next will be divisible by 4. So the number which is divisible by only 2, if you take 2 common from that and from m plus 1 or the other number, then they will become two consecutive numbers which are always co-prime. So if you take 2 common from both of them, they will become co-prime. That means 2 is the only common factor in these two numbers. Okay, and one more thing, that one of them will be a multiple of 2 alone and one of them will be multiple of 4. So this side, right hand side should be multiple of 8 at least. It can be multiple of 16 also. In fact, it has to be multiple of 16 because otherwise, just 1 minute. Just 1 minute. Yeah, let me just complete this thing. I think I was saying what I was saying was correct, but I will put it another way. This will be multiple of 2, other will be multiple of 4, so it has to be multiple of 8 at least. And n is even. For that, I think n has to be even. Why I am saying n is to be even? Yeah, this is my fourth conclusion, n is even. Why I am saying so? Because if n is odd, okay, for odd number, the square of odd is always 8k plus 1 form. So if that is so, n power 4 will be odd and odd square plus 1 would be 8k plus 2. So you cannot take 8 common from that. So n has to be even number. I hope this is clear how I am saying that thing. Okay, now please see. If I write this left hand side here as n square into n square into n square plus 1. So dear all, please understand, n square plus 1 being consecutive integers has to be co-prime. Has to be co-prime. But on the right hand side, I am having two numbers which are two consecutive even numbers. Consecutive even numbers. So we should be able to factorize my left hand side so that factorize in two numbers so that difference of these two is 2. I hope you are getting that. These are two consecutive even numbers whose difference is 2. So I should also be having numbers on the left hand side such that I divide them into two factors and the difference is 2. And how it is possible? You can see n is even. So n square plus 1 is odd. Okay, n square plus 1 is odd. And among these m minus 1 and m plus 1, one of them will be multiple of 2 only. Multiple of 2 only. So I think one of them would be, I think I can say one of the factor has to be 2 multiplied with n square plus 1. Either m plus 1 or m minus 1, because that factor which is only multiple of 2 means if I take 2 out it will become odd. Then I think this n square plus 1 has to get 2 and it will become equal to this thing. I hope you are getting why I am saying so. Okay, please understand, among these two only 2 is the common factor, and here also n square and n square plus 1 are co-prime numbers. So I need to keep only 2 as the common factor so that one of them I can call as m minus 1 and other I can call as m plus 1. Okay, so here other factor would be n power 4 by 2, and this will be integer because my n is even, so n power 4 will be having 2 power 4 in it, so dividing by 2 will also give us even number only. Okay, in fact this n power 4 by 2 will give us that factor which is having multiple, which is a multiple of 4 or 8 or higher power of 2, and this one would be just multiple of 2, not 4 or 8. Okay, now we cannot comment whether this will be m plus 1 or this will be m minus 1 or vice versa. So I think we can conclude the difference of these two, n power 4 by 2 minus 2 into n square plus 1, has to be either 2 or minus 2, because I don't know which one would be bigger, which one will be smaller. So here this is how we will be doing it. Let me take another slide to solve the remaining part of this question. So I think this is what we have done so far. So let me write this as n power 4 minus, if I multiply by 2 both side, it will be 4 n square minus 4. Yes, and this will be either 4 or minus 4. Now if I take first case, so n power 4 minus 4 n square minus 8 equal to 0, this does not give any integer roots. You can see the discriminant comes out to be 16 plus 32, not a perfect square. So we cannot get rational root for this thing, for this quadratic. But if I take other case, n power 4 minus 4n square minus 4 is equal to minus 4, then it will become 0. In this case, my n square will be 4, and we are looking for natural numbers n. So only value of n will be 2. Okay, so answer for this would be 1. How many natural numbers they are asking? Dear all, let me tell you, some people may say that this 2 was very much visible clearly. How? You can say that n power 6 is n cube whole square. Then I write 1 as 1 square, and then I can write this as n into n cube. So in order this to become perfect square, I think n is equal to 2 is a choice, isn't it? Because then it will become a square plus b square plus 2a into b. So n is equal to 2 has to be the answer. But this will only be able to tell you that n is equal to 2 is one of the answer. But how it will tell you that n equal to 2 is the only answer? So for that, I think we should do the complete analysis. Then only we can conclude the answer will be 1. So this completes the solution of this question. I will again say this was a medium to difficult or medium type question. Okay. Now coming to the next question, that is 7. It says a broken calculator has all its 10-digit keys and 2 operation keys intact. Let us call these operation key A and B. When the calculator displays a number n, pressing A changes displays to n plus 1. That means it will add 1 to that previous number. When the calculator display a number n, pressing B changes the display to 2, and that means it will make it double. For example, if 3 is in the display and keystrokes A B B A. So first A will make 3 to 4, increasing it by 1. Then B will make this 4 to double to 8. Then next B will make again this to double to 16, and then next A will make it by increase it by 1, so it will become 17. Okay. Now they are saying if 1 is on the display, then what is the least number of key strokes needed to get 260 on the display? Now please understand. If I want my number 1 to become 260, I want to increase it. Okay. Now you can understand this pressing A increase only by 1. But if you press B, it will increase by more than 1, or in worst case only 1 when you are just pressing after 1, because 1 will become 2 in 2 ways: by pressing 1, by adding 1 also, or by making it double also. But in other cases, B will make a big difference in my existing number to next number. So if I want least strokes needed, so I need to make B as much as possible and A as less as possible. Okay, but as you can see, if I keep on pressing B only, I cannot get 260 from 1, because every time I press B, it will become double. So 1 will become 2, 2 will become 2 will become 4, and so on. And in this series 4, 8, 16 and so on, we will get 256, but we cannot get 260. So only having B is not possible. But please understand, I think this is simple observation that 1 goes to 2, goes to 4, goes to 8, goes to 16, goes to 32, goes to 64. If I press A key here, which will give me 65 from 64, and then I make it double, so 130 and then 260. You can see we will be able to obtain 260 from this 1. Okay, you could have done it opposite also, that if I make 260 half, it will be 130, again make it half, it will be 65. But you cannot get a number previous to 65 by doing it half, because we are having only integer. So by subtracting by 1, it will be 64, and then only B will be able to get the numbers starting from 1 to 64, and then pressing A, and then pressing B, and then pressing B. So here you can see from 1 to 2, you have option that you press A or B, then B, then B, then B, then B, then B, then A, then B, and then B. So you can see I am only pressing 1 times A, 1, so first B, then B, 1, 2, 3, 4, 5, 6 times B, 3, 4, 5, 6 times B, then A, then 2 times B. Okay, so this is the smallest possible strokes I will need it. Why I am saying smallest possible? Because it is not possible to go without pressing A, and I have pressed A only once. So I think this is sufficient to say that that is the least possible number of strokes I needed to press. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 would be the answer. In fact, you could have taken instead of B at first place A also. That will also give you 9 only. So A, B, B, I think 5 times B here, then A, then B and B. Okay, let me just check once again whether I am not making a mistake. So 1 goes to 2 in first step, then 4, then 8, then 16, then 32, then 64, then 65, then 130, then 260. So total is 9. Yeah, absolutely 9 is the answer. Okay, I think this was also not very difficult question, I will say. In exam, you may get pressurized, you may think that how to do it, but it was not difficult question. I will rather call this as a medium or slightly lesser than medium. I will rate this question as. Okay, now coming to next question, that is question number 8. It says pi is equal to pi 1, pi 2 and so on, pi n be a permutation of numbers 1, 2, 3 and so on n. We call pi has its first ascent at position k less than n if pi 1 is greater than pi 2 greater than pi k and so on, and pi k is less than pi of k plus 1. So pi has first ascent at position k if till k, if you move on, the values are decreasing and then it increases. After that, they are not saying it should further increase or not, but till k it should decrease, then after k it should increase. Okay, so if pi 1 is greater than pi 2 and so on, and pi n minus 1 pi n. So we are given n numbers which all are different in increasing order or decreasing order. You can place all of them, and we say pi has its first ascent in the position n. Okay. If all the numbers are in that decreasing order, then you can say the first ascent will be at nth position. Although we may not be able to compare with the n plus 1th position because we are having only n numbers in this sequence, but yes, they have defined it separately. Then we will call this as the nth ascent, and we will call this as the ascent in the position number n. For example, if n is 4 and numbers are, let us say, 1, 2, 3, 4, then this permutation 2, 1, 3, 4 is having first ascent at position number 2. You can see 2, then 1, it is decreased, but after 1 it is increasing. Okay, in my opinion, this number, if this would have been like this, if this way, 3, 1, 4, 2, then also I think we will call ascent at position 2, because you can see second position, the number till second position it is decreasing 3 to 1, then it increases, and after that we are not supposed to check what is happening. So here also we will call that first ascent at position number 2. Now the question is, find the number of permutations which have their first ascent at position number k. Okay, so what we are going to do first, let me make 1, 2, 3 and so on k here, k plus 1 and so on n. So this is my kth position, this is my k plus 1th position. So I want that numbers to decrease till this point of time, and there should be a jump after this kth position. This is what I am looking for. So one of the idea here is that I choose k numbers from my n numbers. Okay, and I place them in first k positions in decreasing order in one way only. I hope that is clear. I chose k numbers out of n, as they all are different. There will be only one order in which I can place them in descending order. Okay, and after k I want a bigger number. Now the problem here is that you cannot guarantee that you will be now left with a number which is bigger than the number at the kth position. For example, if you chose all the bigger k numbers, or biggest k numbers, then all the remaining numbers would be which all are lesser than whatever number you put at the kth position, isn't it? Which means in this way it will depend upon actually which k number you have chosen. Maybe they are all smallest k numbers or biggest k numbers or some other combination. So this way it becomes, I think, little bit confusing or difficult, but there is one way. Please understand what it is. Suppose I ignore this fact. I ignore that fact that my k plus 1th number is bigger than k or not. I just focus on that all the numbers I put in first k places, they are in decreasing order. Okay, then I will be left with n minus k numbers here, and I can place them in any order of my choice in n minus k factorial ways. But you will argue that this will not make sure that k is that my first ascent is at the kth position. So to make sure that, what I am going to do, please listen carefully. If I do this same calculation once again and I take k plus 1 number now, out of n I take k plus 1 number now, and I do the same thing. I decrease them till k plus 1th number. I decrease them till k plus 1th number and again rearrange the remaining numbers, n minus k minus 1 factorial here. Okay, so now you will understand that these number of cases are actually subset of this, yes or no? These cases, if I call this as set A and this set B, set A is when all the numbers are decreasing till kth position, and this is where numbers are decreasing till k plus 1th position. So this A is a bigger set because A is having those cases also in which after k and you move to k plus 1, your number may increase. But in B, we have taken those cases in which till k plus 1, all the numbers are decreasing. So if I subtract these cases from this, I hope you understand what I'm saying. I have removed all those cases in which this descent is going till k plus 1th position. Okay, and if I do so, then I think out of this A, I will be left with only those cases in which from k to k plus 1, I have to have ascent, isn't it? Because if k to k plus 1, it is again a descent, it is decreasing, then it will be there in B. So if I am decreasing these number of cases from this, I will get what I need. Okay, so the answer for this would be nck into n minus k factorial minus nc k plus 1 into n minus k minus 1 factorial. I think I can leave this question here only, although you can take n minus k minus 1 factorial common also, and maybe something will be, let me see if some simplification is possible or not. If I take this factorial common, okay, and n factorial upon this will be k factorial n minus k factorial here I will be left with n minus k and minus this will be n factorial upon k plus 1 factorial, and this will be n minus k minus 1 factorial here. Instead I should have multiplied this. Yes, let me do the calculation here. I should have written this as n factorial upon k factorial, n factorial upon k factorial, because n minus k factorial will be cancelled, and same thing will be done here also, n factorial upon k plus 1 factorial. I think this one is better. Okay, so you can take n factorial upon k factorial common, and this will be 1, and here it will be minus k plus 1. I think I can leave it here only. That is the answer. Let me leave this here only. Okay, so this completes the solution of this question number 8. Now coming to next question, that is 9 and 10. Here they have given, for question 9 and 10 below, some statements are given. For each statement, we have to tell whether it is true or false. Write your answer to each question as a sequence of 3 or 4 letters as T for true, F for false in correct order. Okay, so this is the first question. Please see. Here we are given that f r into r to r. So the domain of this is actually Cartesian product of two sets r and r, and the codomain is r here, and this is defined as a to b, f of a comma b equal to limit n approaches to infinity 1 upon n log e base natural log of e power n a plus e power n b. Okay, now everybody please listen carefully how these questions this can be done directly. You know that exponential function rise very rapidly as your power becomes more. So here, if my a is bigger than b, I can say this e power nb will be very less as compared to e power na. Okay, so if that is the scenario, then it will be 1 upon n, and I can write this as ln, okay, and just e power na here. I have ignored e power nb, although it will be very huge number in absolute terms. But if you compare it with e power na, it is like you are comparing, let us say 10 power, let us say 10,000 with 10 power 100. 10 power 100 is a big number, but it in comparison with this is very small number. So we can ignore this thing. I will tell you another method of this thing. Okay, and here after calculation you can see it will become just a, because ln of e power n is na, and will get cancelled. Okay, similar to this it will be b for when a is less than b. For a equal to b also you can choose any one of them, either a or b, it will be same thing. You can put it here also, you can check, it will become only a. Now I'll tell you another way of doing the same thing. Can we write this as limit n approaches to infinity and assume a is greater than b? A is greater than b, and I will write this as ln of e raised to the power na, and then 1 plus e raised to the power nb upon e raised to the power na. Okay, let me write this as limit n approaches to infinity 1 upon n. Then using property of log, I can write this as na plus ln of 1 plus e power nb upon e power na. Okay, now you can see n will cancel it, limit n approaches to infinity. We can write this as a plus 1 upon n into ln of something that is bigger than 1 but lesser than 2. Okay, because a is greater than b, so e power nb upon e power na, that will be less than 2. Even if a is equal to b, it will be less than or equal to 2. And ln of 2 will be a finite number, or yeah, finite number I can say, and which divided by n, which is infinity, will give you a plus 0, that is a only. So this is how we can very easily say this will be just a, and in this another case it will be b. Okay, now let me take another slide to solve further. So after knowing that it would be equal to either a if a is greater than or equal to b, and it will be b if a is less than b. Okay, now first question is a is not onto, that is range of f is not all r. Now please understand, I am free to choose any a or b of my choice because my domain is r into r. In fact, every number in the r you choose, you can make ordered pair with any other number. Okay, so here I think range has to be all real number. I hope you are getting it. You can think of this way, that let me write this f of a comma b, f of a comma, let me say x. Okay, this will become x if x is greater than or equal to a. Now I can choose any value of a. I can choose a as small as possible, maybe minus infinity, something of that sort. You can say my x can take any value from minus infinity to plus infinity. So this function has to be onto. So saying that not onto is false. Okay, I will tell you this in another way, that choose any number from entire real number. Okay, and I will tell you how you can obtain that as the value of this function. For example, if you say I want how this value can be 10 power minus 100. Okay, suppose I want how the value 10 power minus 100 that is lying in this R can be the value of this thing. So I just have to choose one A which is lesser than 10 power minus 100. Okay, maybe 10 power minus 200, and then 10 power minus 100. I think this will give you 10 power minus 100, and this way you can see any value of your choice can be the value of this function. So this function has to be onto, not onto, so this will be false. Now for every value of a, x to f, a comma x is continuous everywhere. For every a, the function x to f, a to x. Okay, so we have fixed a. So if I fix my a, I think you will understand easily. This graph would be that if my x is lesser than a, if x is lesser than a, the graph will go like this, where y is equal to a, and when x will become greater than a, it will go like this. This is x is equal to a. I think I have not made this line properly. This line will be a constant line, you can say. So whatever a you choose, if your x is lesser than a as per this definition, the value of function will be a only. But as your function, this x become bigger than a, it will take value equal to x. So it will go with the slope equal to 1. Okay, but there will not be any point of discontinuity. So the function will be continuous everywhere. So it seems to be true here. Now, for every b, the function x, f of x comma b is differentiable everywhere. I think this is similar to this only, but here as you can see there will be a corner point. There will be a corner point. That means it is not differentiable everywhere. So answer will be false here. Now, for f 0 comma x, it will be x for all x greater than or equal to 0. I think this is very much obvious from this. I just have to take a as 0, and because x is greater than or equal to 0, so the value has to be x. So this is true. So the correct sequence of false, true, true, false would be that first is false, then it is true, then false, and then true. So this is the answer of this question. Okay. Now coming to the next question. It says f r to r, there is no continuous function for which 0 to 1 fx into 1 minus fx dx is less than 1 by 4. Now dear all, this one is one very popular question, I will say. I have seen this question at many places. So this you can check, fx into 1 minus fx dx can be written as 0 to 1. I will write this as 1 by 4 minus fx minus 1 by 2 whole square dx. Okay, this is what we can write. Now, this is always going to be positive because that's a perfect square. So this integral has to be lesser than or equal to 1 by 4. So saying that it will be less than 1 by 4, I think that is very much true. So saying that no continuous function f, I think I can take many continuous functions for which this will be less than 1 by 4. So this a seems to be false. Okay, now there is only one continuous function f for which this will be equal to 1 by 4. This seems correct, but beware. There is one very big catch in this question. Please see. It looks like this will be 1 by 4 only if fx is equal to 1 by 2. But please understand, fx is equal to 1 by 2 when x is between 0 to 1. Yes or no? Between 0 to 1, my fx has to be 1 by 2. But who will stop you if you change the value of fx from half when your x is bigger than 1 or it is lesser than 0? I hope you are getting what I am saying. So between 0 to 1, this function has to be half. Between 0 to 1, it has to be half. But after 1, before 1 by 2, you have infinite choices. For fx, how, whatever way you can move it, it will still remain continuous. So there is only one continuous function f for which this is equal to 1 by 4 is again false, because there are infinitely many continuous functions f for which this will be equal to 1 by 4. So here correct sequence would be f, f and t. Okay, so these two questions, if I say this was not easy, I will put this into category of medium to difficult, because there were many things to be considered here. And here also I will say this was a little confusing, especially this B part and C part. So I will also call this as a medium to difficult. Okay, so these were the 10 questions in that exam, and this is how I have rated them. You can see first question was from PNC based on number of divisors. I call this as a medium. Phi 1, phi k, if you remember that question. Then differentiation question where there was a correction. dy upon dx as slope was to be used. It was easy. Then this question of rectangle 2a plus b is equal to 60. I have kept this into AOD, although it may be kept in AMGM also or quadratic also. So it is also easy question. Then sequence and series at 1, 1, 1, 1, 3 times and so on. This is also easy, or rather I will say medium also. Because here there was a catch that whether you are able to understand how many number of terms are there. Then probability question was medium, that question based on chessboard. Okay, then number system Diophantine equation, I will call this as a medium to difficult, n power 6 plus n square plus 1. Then there was another question, number system, what was that, let me check. 7th, yeah, this broken calculator, yes. So this was just a question of number system. I don't know which subtopic I should put it into, but it was easy question. Then next question, PNC, yes, arrangement is constraint. That question at in which there was number of arrangement was asked in which first ascent will occur at k. So that was difficult question, I will say. It was not that easy. Then function LCD based question, difficult. And then definite integration, it is a medium question. So this is how all the questions of this part A can be described, I will say. Now it is a time of teaser question, and you will love this question. But before that, let me tell you everybody, those who are going to prepare for JEE Advanced, Vedantu Eklavya is one very big thing you should know. We are preparing students on online domain, and it is with the convenience of your home, and you will be able to get the quality which you may not get in many of the offline coaching. So just Google it, you will come to know about this Eklavya. This is the notice board of all the batches going on in Eklavya, or topper part of this Vedantu. You will find this notice board in PDF format. This is the QR code for the same. We are putting all important information regarding new batches coming up or new things going on in these batches. So please follow it. You will come to know all the updates here. Those who will be writing JEE Advanced in 2023, please join Telegram channel using this link or this QR code. It is given in the description box also. We will be putting all important information regarding Eklavya 2023 here. Same for 2024 students. Dear all, in this YouTube channel, this V-Impact YouTube channel, we are putting JEE Advanced Solutions, KVPY, ISI and CMI solutions. So do watch, and the solutions you will be finding question wise, and alternate solutions also you will find there. So please subscribe this channel. You will be able to find many solutions there, and some solutions will be really unique. You will not find them anywhere else. Now dear all, this is a teaser question. This question is that if pi, pi means continued product, r is equal to 0 to infinity, 1 plus x upon 2 power r plus x square upon 2 power r. That means my first term would be 1 plus x square. Then if you put r as 1, this will be 1 plus x upon 2 plus x upon 2 square and so on. And this goes up to infinity. If you multiply all such terms and you write this as increasing power of x, we call this as 1 plus a1x plus a2x square and so on. This will also go up to infinity. then you have to find the value of this expression A100 minus 8A97 upon A100 minus A99. One very challenging problem, very good question. Please try it. You will have a fun in this question. So that is all for today, dear all. If you have solved this question, do not forget to send the solution to this eklavyaSupport@vedantu.com with subject line teaser solution maths. We will check your solution. If we like it, we will reach out to have interaction with you, and we will try to have with us in one of our batches. Okay, so that's all for today. Thank you so much. Take care. Bye. And in next session I'll be taking part B of the same paper, CMI 2019. Okay. Bye everyone. Take care.